Alright guys, so what we're looking at today is multiplying, dividing, and complex rational expressions. It just says fractions, but we're talking about rational expressions. So the first thing we're looking at is multiplying. So we're going to multiply these two rational expressions here. Now when we multiply rational expressions, we're multiplying the top and bottom, but we're also simplifying anything that's in common on top and bottom. So before we start multiplying and combining things together, like we've done this once already, it might be easier to simplify out what we can tell is already in common on top and bottom. So one thing I notice here is I have a 3 and 3. Because again, when we multiply, these are going to be on the same, top and bottom. So this 3 will eventually cancel out with this 3. So why not do it right now? Because those two we can see simplify easily. Now 4 over 2, 4 divided by 2. Well, the 2 will become 1, and the 4 will become 2. Now the 3 and 3 really simplified to 1, but we're good. So we'll see what's left over on top so far. So we have a 2 on top. Now let's see what's on bottom. Well, y and y cubed, 3, and this is to the first, 3 minus 1, because when we have like bases that are being divided, we subtract the exponents. Well, 3 minus 1 is 2, and since it's bigger on top, it stays on top. That simplifies out, and that becomes a 2. The same thing with x. 2 minus 1 is 1, and since it was bigger on top, it stays on top. So that there is our answer. Now if we talk about restrictions, since x simplified out of the denominator, x cannot be 0, and y cannot be 0. And that's it. That's all we need to do for this problem here. And we did a bunch of those already, and we've done those before. So let's look at one that's a little more complicated. So here we have x minus 5 times 7 over x cubed minus 5x squared. Now the x minus 5 is really over 1. Now the reason I haven't written in the x cubed minus 5x squared is that we need to simplify it. Because if we can simplify or factor anything in these rational expressions, we need to do that, especially with multiplying. And when I look at this here, let's get a highlighter. When I look at this here, there is a greatest common factor between these two terms. And that greatest common factor is x squared. So we can factor it out. Now if I factor out x squared from x cubed, I'm left with just x minus x squared factored out of 5x squared leaves me with 5. And now at this point here, we can multiply them together so they end up all be on the same fraction. And we can cancel out what's in common. Well, the x minus 5 and x minus 5 on top and bottom would cancel. And what that would leave us with is 7 over x squared. And now we need to look at our restrictions because we've simplified this as far as it goes. This is as simplified as it gets. And now we just need to look at the restrictions. Well, since x squared is still here, we don't have to include it as a restriction, but we need to include the x minus 5. And what value of x will make x minus 5 equal 0? Well, that is 5. Okay. We're looking at this one here next. Ooh-wee. So we have two things here multiplied together. Now when I look at this here, x plus 2 squared, well that's just telling me that I have x plus 2 times x plus 2. I have those being multiplied together. Over 6x squared, 3x. Now, all of these here have been pretty easy so far. X plus 2 squared is just x plus 2 times x plus 2. 6x squared is just 6x squared. There's no way that we can simplify that. And 3x is as simplified as it gets. Now, x squared minus 4, we can factor that. 2 sets of parentheses. Now this here is a difference of perfect squares because x squared is a perfect square and 4 is a perfect square. So what that'll give us is x plus 2 times x minus 2. And then we can multiply these together. And I haven't been doing this of late, but if we multiplied them together, we would get 3x times x plus 2 times x plus 2 all over 6x squared times x plus 2 and x minus 2. Because we can rewrite it back out. And if that's easier for you to be able to solve, do it that way. Now we need to cancel out what's in common. Well, we have an x plus 2 and an x plus 2 on top and bottom. That would cancel. 3 over 6. A 3 would cancel out with one of the 3's in 6. Or, well, 3 divided by 6 is 1/2. So we have 1 over 2. And the last thing is we have these x's here out front. And when the bases are the same, we subtract the exponents. So that would simplify out completely. And the x squared would become x to the first. And what that leaves us with is x plus 2 on top, because that's the only thing left in the numerator, in the top of this fraction. Now, at the bottom of the fraction, we have 2x times x minus 2. And that's it. Now, we can't simplify anything else out because the x plus 2 on top is stuck together, so we can kind of write parentheses around it. Because this x and the 2x won't simplify out because it's stuck with the x plus 2. Now, so this here is our answer. And we do need to find our restrictions. Let's see what x cannot be. So the only thing that simplified out completely was the x plus 2. And what value of x will make x plus 2 0? Well, that would be negative 2. And that's all we have to do here. All right, let's look at this one here. Now, some of our simplifying is going to be pretty easy to see for this one here because we can kind of see it as we look at it. Now, we look at the first part. Well, we have 3x plus 2. 2x minus 1. 3x plus 2. All of these here are pretty straightforward. We can see that those are what they are, and they work out just fine. Now, the only reason I didn't write the last one is, well, when I look at this here, 4x, negative 4 plus 8x, I notice that there is a greatest common factor between these two terms. And that greatest common factor is a 4. So we can factor it out. Now I'm going to switch it back around so that we have x in front. So if I factor 4 out of 8x, I'm left with 2x. Minus, if I factor a 4 out of 4, I'm left with 1. Because anytime everything factors out, it simplifies to 1. And now we can cancel out what's in common, or what simplifies on top and bottom. And because these are all being multiplied together, that's why we can simplify this. Being multiplied together, so they're all the same thing. So if I was really to write this back out as one set of terms, the numerator would be 4 times 3x plus 2 times 2x minus 1 is what we would get in the numerator. Now the denominator would be 3x plus 2 times 2x minus 1 is what we would get. And seeing this here, because they're multiplied, the 3x plus 2 and the 3x plus 2 would cancel. The 2x minus 1 and 2x minus 1 would cancel, leaving us with our final answer of 4. And that's it. That's all we have to do for this one here. Now it would be good to find our restrictions. So our 3x plus 2 canceled out on top and bottom. So we can set it equal to 0. And our 2x minus 1 canceled out on top and bottom. So we'll set it equal to 0 and see what these are. Well, 3x plus 2, the first thing I would need to do is subtract 2 from both sides. And when I subtract 2 from both sides, these will cancel, leaving me with 3x is equal to negative 2. At which point we can divide both sides by 3. And we see that x cannot equal negative 2 thirds. We can do a similar thing with the other one, so we can add 1 to both sides. Because again, we're just trying to solve for the value of x. Because adding 1 would get those to cancel, leaving me with 2x equals 1. And again, at this point, we can divide both sides by 2. And when we divide both sides by 2, we get that x is equal to 1/2, and because this is our restriction, x cannot be these two values here. And we simplified to find that the multiplication was just 4. Okay. Now we're going to look at some little bit more complicated ones. These here are not really that much more complicated. It just requires us to factor. Because once we factor them, multiply them together, then we can simplify out what's in common on top and bottom. So I'm just going to start off with our 2x squared plus 7x minus 15. Now for this here, we're going to have 2 sets of parentheses. Now since the 15 is negative, the sign in one of them is going to be positive. The sign in the other is going to be negative. And that's just from 15, because the third term is negative, the signs are opposite. Now we can look at the factors of 2x squared. Well, we're going to have 2x and, well, just x. Because those are the factors of 2x squared. There'll be 2x and x. Now, next we need to look at the factors of 15 and see what factors of 15 would give us 7. So we have 1 and 15, 3 and 5. Let's try 3 and 5. And if we try this here, well, 2x times negative 5 will give us negative 10x. And if we do the other one, 3 times x would be plus 3x, which is equal to negative 7x. Okay, so we almost got it. We just need to flip the signs. Because if we flip the signs, the 3x would be negative and the 10 would be positive, which would give us a positive 7x, which is what we wanted. So the factors of 2x squared plus 7x minus 15 is 2x minus 3 times x plus 5. So we get this here. Okay, let's move to the bottom of the first fraction. Now again, we're going to have 2 sets of parentheses. Now because the 3 is positive, the signs are the same and they match the sign of the middle term, which should be negative and negative. Now the factors of 4x squared, well, we know the factors of x squared are going to be x and x. And I'm just going to pick 2 and 2 for the factors of x squared. Now the factors of 3 are, well, 1 and 3, because those are going to be the only factors of 3. Now if we check this here, 2x times negative 3 would be negative 6x. 2x times negative 3 would be negative 6x. Negative 1 times 2x would be negative 2x. And negative 6x minus 2x is negative 8x, which is what we wanted. That would be the middle term. So these here are the factors. Okay. Now that brings us to the numerator of our second set, or our second rational expression, our 2x squared plus x minus 1. Since the one is negative, it means our signs are going to be opposite. One's going to have a plus and the other is going to have a minus. Now the factors of 2x squared, well, the factors of x squared are just x and x. And the factors of 2 are 2 and 1. And it works out the factors of 1 are 1 and 1. Now we just need to see if this is the correct set of factors. Well, we do 2x times negative 1, which would be negative 2x. And 1 times 1 would be, or 1 times x would be plus x. This gives us a negative x. Okay, well, not quite. So we need to flip the signs. So it'd be positive and negative. And if we do that, it'd make it 2x minus x, which would give us a positive x. And that's exactly what we wanted. Now that brings us to our last set of parentheses. Now because the 5 is positive, the signs are going to be the same. So this one down here, the signs are going to be the same. And they're going to match the sign of the middle term, which is positive. So they're both going to be positive. Now we look at the factors of x squared, which would be x and x. And the factors of 5 are, well, 1 and 5. And that ends up being the factors. And we could check it and see, but those would be the factors that we would get. Now again, we can multiply this and have these all on the same equation, on the same set. So it'd be 2x minus 3 times x plus 5 times 2x minus 1 times x plus 1. And in the denominator, we'll have 2x minus 1 times 2x minus 3 times x plus 1 times x plus 5. And now at this point here, we need to simplify out what's in common on top and bottom. Well, 2x minus 1 and 2x minus 1 would cancel. X plus 1 and x plus 1 would cancel. X plus 5 and x plus 5 would cancel. And 2x minus 3 and 2x minus 3 would simplify out. Well, wait a minute. Everything simplified out, so our answer is 1. 1. Since everything simplified with the numerator denominator, it became 1, because anything divided by itself is 1, and since everything divided by itself, it all simplified to 1. Now we can look at the restrictions here. It would just be setting each one of these equal to 0 and solving. And if we did that, we would get negative 1 from our x plus 1. We would get negative 5 from the x plus 5. So from these two here. Now the 2x minus 3, if we plug that in and solved, we would get 3 halves. And if we did it with the 2x minus 1, we would get 1 half. So these here would be our restrictions, and our solution is 1. All right, we're going to look at one more multiplication and then we'll move on to division. So the first thing we need to do is simplify or factor anything that we can. Now looking at this here, x squared is as simplified as it gets. Now x squared minus 16 on top, that is a difference of perfect squares, which means that this is going to be x plus 4 times x minus 4. And again, those are kind of nice. They're easier to work because we know difference of perfect squares. X and x, 4 and 4. And we have our sets of parentheses. Now the next one we can look at is this one here, x squared minus 4x. Well, I notice they do have a common factor of x, so we can factor it out. And if I factor that x out, x factored out of x squared would be x minus. If I factor an x out of 4x, I'm left with 4 over. So the last thing we need to factor is our x squared minus x minus 12. So we're going to have two sets of parentheses. Because the 12 is negative, one of them is going to have a plus, the other is going to have a minus. Now the factors of x squared are going to be x and x. And now we need to find the factors of 12. Well, it works out that it would be 3 and 4. They're going to be our factors of 12. Now, since we have everything factored, we can go on and multiply everything together. So the numerator would be x times x minus 4 times x minus 4 times x plus 4. And how we arrange these really doesn't matter. We have two x minus 4s on top, and x plus 4, and then x. Now on bottom, we have an x squared times x plus 3 times x minus 4. Okay, now that leads us, since everything's simplified and we've got it all multiplied together, we can see what's similar on top and bottom. Well, the x minus 4 and x minus 4 would cancel. And this x is going to simplify out with one of these x's. And that's it. That's everything that's in common on top and bottom, simplified down. So if we look at this here, well, what we have left, our answer, on top is going to be x minus 4 times x plus 4. And in the denominator, we're going to have x times x plus 3. And this here is our final answer. And we do have one restriction. Because this x plus 4 simplified out in the denominator, we need to see what value of x would make it 0. And that would be 4. So that's all we have for this here. Now when we're dividing, because here we'll look at some division problems. When we're dividing two rational expressions, the first thing that we really need to do is rewrite it as multiplication. Then we can factor, and then it'll be exactly like we were doing with multiplication. So the first thing I'm going to do is I'm going to rewrite it as multiplication. So the first rational expression stays the same, 7x cubed over z, but the second one flips. And if we look at this here, well, there's nothing in common on top and bottom in any of these here, so we can just go on and multiply them together. 3 times 7 would be 21, x to the third. 5z cubed and z would be 5z to the 1/4. And that's it. And because nothing's simplified out on top and bottom, we don't have anything that's completely gone. We don't have any restrictions for anything here. So this here would be our final answer. Okay. So we'll look at this one here. This one here will be a little bit more in depth, or have a little bit more to it than the last one. Now if we look at any of this here, the first thing we need to do is change it from division to multiplication. So x squared minus 9 would stay on top. The x plus 4 in our first expression would stay on top. Now the second rational expression will flip, which will give us x plus 4 on top and x minus 3 on bottom. Now we can simplify out anything, or we can factor anything that needs factoring, and there's one thing that needs to be factored. So if we look at this here, well, x squared minus 9. X squared minus 9 is a difference of perfect squares, which would give us x minus 3 times x plus 3 on top. On bottom here, we would have x plus 4. On top here, we would have x plus 4. And on bottom, we're going to have x minus 3. And these here are being multiplied together. So we can go on and multiply them, or we can simplify. Either way, it still works the exact same. So if I multiplied them all together, what I would get on top is x minus 3 times x plus 3 times x plus 4 is what I would get on top. Now on bottom, I would have x plus 4 times x minus 3. Now at this point here, we can simplify out what's in common on top and bottom. Well, x minus 3 and x minus 3 would cancel, and our x plus 4 and x plus 4 would cancel, leaving us with x plus 3. And that there is our answer. So this here is the final answer. And we do need to look at our restrictions, see what values of x we cannot have. And so when we look for the restrictions, really, grab a highlighter. We're looking at the denominator here and the numerator of our second fraction, because anything in these three spots cannot be 0. Nothing in these three spots can be 0. So when we look at this here, so here x plus 4 is still left in the denominator? If it is, and I mean, so, okay, let me back up just for a second. So we're looking to see where x 0 in these three spots. Now if any of these three spots is still in the denominator in our answer, we don't have to list it as a restriction. But if it's still there and it's in the numerator, we need to list it as a restriction, because it's still a restriction. So when we look at this here, well, x plus 4, that would be negative 4, because negative 4 plus 4 would give me 0. Now the next one would be our x minus 3. Well, that would be positive 3, because 3 minus 3 is 0. And our last one, x plus 4, okay, well that'd be negative 4 still. So these here are all of our restrictions, and that's all we have to do for this here. Okay, let's look at this one here. So when we look at this problem here, so we're still dealing with division. And even though that this here, x plus 3 squared, doesn't have a denominator, it still does, it's just 1. So the first thing we want to do is we want to rewrite this as multiplication. And to do that, we keep the first one the same. X squared plus 8x plus 15 over x squared times 1 over x plus 3 times x plus 3. And I went on and just wrote that out. Okay. Now we can factor anything that is factorable, and there are a few things. X squared is not factorable. And our x plus 3 times x plus 3 is not factorable either. And we have 1 on top. Now this other one, the x squared plus 8x plus 15, it is factorable. Now because the 15 is positive, the signs are the same and they match the sign of the middle term, which would be positive and positive. Now the factors of x squared are going to be x and x. And now we need to look at the factors of 15. Well, we have 1 and 15, 3 and 5. Well, we can use 3 and 5, and those will be the factors that work for this here. Okay, now we can multiply these together. Well, the numerator, x plus 3 times x plus 5 times 1 is just going to be x plus 3 times x plus 5. Now the denominator, we will have x squared still. And this here is going to be multiplied by, move this over just a little bit, x plus 3 times x plus 3. And now we can simplify anything that's in common on top and bottom, which would be an x plus 3 and an x plus 3. Which leaves us with, because everything else, nothing else simplifies besides that, with an x plus 5 on top, and an x squared times x plus 3 on bottom. So when we look at this here, so again, as I said, because that's our final answer, we just need to look for our restrictions. So our restrictions are going to come in one of these 3 spots. And we look back here, so x squared, well, x squared is still in the denominator, so we don't have it as a restriction. X plus 3 and x plus 3, well, there's still an x plus 3 in the denominator, so we're good there. It's still considered a restriction, and 1. So all the restrictions that we could have are still listed in the denominator, then the bottom of our fraction of our solution. So we don't have to list any restrictions for this here. So we're done. All right, we're going to look at one more of these here with division, and then we'll move on to the last type, our complex rational expressions, our fractions and fractions. Now the first thing we can do is change it from division to multiplication. So our 12x squared minus 22x plus 8 on top, 3x stays the same. Now the second fraction flips, so we'll have 2x squared plus 4x on top, and on bottom we'll have 3x squared plus 2x minus 8. So we changed it from division to multiplication and flipped the second fraction. Now what we can do next is we can go on and multiply these together. Well, to multiply them together, we really need to factor them. And if I'm looking at this first one here, so it's going to take a few steps to factor this. I notice that there is a greatest common factor of 2 that we can factor out. And if I factor it out, I'm going to be left with 6x squared minus 11x plus 4. It might be tempting to say that we could factor it by 4, but 22 is not divisible by 4. It's only divisible by 2, so we can only take a 2 out. 3x does not factor at all. Now 2x squared plus 4x has a greatest common factor of 2x. So we can factor 2x out of 2x squared. The 2 factors out completely. And if I take 1x out of x squared, I'm left with x. Plus, if I factor a 2 out of 4x, 2x out of 4x, if I factor 2 out of 4, I'm left with 2. And the x factors out completely, so I'm left with 2x times x plus 2. Now in the 3x squared plus 2x minus 8, there are no greatest common factors, so we can go on and factor this out. Since the 8 is negative, we're going to have one positive and one negative. And at this point, why don't we flip it? Because we've been having to flip it every single time, so I'm just going on and flip it. Now we need to look at the factors of 3x squared. Well, we know the factors of x squared are going to be x and x. And our factors of 3 are going to be 3 and 1. Now we need to look at the factors of 8. Well, the factors of 8 are 1 and 8, 2 and 4. So let's try 2 and 4. And if we try this here, well, 3x times 4 would give us 12x minus 2x, which would be 10x. Okay, that's not what we wanted. So we'll need to change our numbers. We'll flip the 4 and 2. And we can try this again. So 3x times 2 would be 6x. Negative 4 times x would be negative 4x. Is equal to 2x. And that's what we wanted. So here are the factors for that one there. Okay. So we need to do this one more time because we still need to factor the 6x squared minus 11x plus 4. Now everything else will stay the same. I'm going to go on and just copy that down there. And this 3x will stay the same. So now we just need to factor the numerator here. So we are going to have two sets of parentheses. Now because the 4 is positive, the signs are the same and they're going to match the sign of the middle term, which will be negative and negative. Now the factors of 4 are going to be, or 6x squared are going to be x and x. Now we need to determine which factors of 6x we need to use to get 11. So I'm going to try 2x and 3x to start with. Now we need to look at the factors of 4. Well, we have 1 and 4 and 2 and 2. Now we could try 2 and 2, but if we try 2 and 2, we would have 2x and 2x, because if I try 2 and 2, well, that would give me a greatest common factor in our first parenthesis, the 2x minus 2, so we can't have that. So we need to try 1 and 4. And if we did it with 1 and 4, this would be our sets of factors. So these would be the factors that we're looking for here. Okay, now that we have everything factored, we can go on and multiply this all together. And we multiply this together, well, 2x and 2 will multiply together. And 2x times 2 will give us 4x times 2x minus 1 times 3x minus 4 times x plus 2 on top. And on bottom we'll have 3x times 3x minus 4 times x plus 2. Okay. Now we can simplify out what's in common on top and bottom. Well, the x and x will cancel. Our 3x minus 4 and 3x minus 4 will cancel. And lastly, the x plus 2 and x plus 2 would cancel, leaving us with 4 times 2x minus 1 on top, and on bottom we would have 3. And this here would be our final answer. Now we do need to look at our restrictions. And when we look for our restrictions, go back to the highlighter, we're looking at this spot here and these spots here, and seeing also if they still show up in our final answer. When we look at all these here, well, the x is not there anymore, so we have to say x cannot be 0. So x cannot be 0 is one of our answers. Now we'll look at the other two. So we have 3x minus 4. Well, it's not left in the denominator anymore. And if we solved it for see where x would be 0, it would be 4/3. And then we have x plus 2. Well, it's not on bottom, and it would be -2. Now on top of the second fraction, x plus 2 and x have already been taken care of, so we don't have any other restrictions. So our final answer was 4 times 2x minus 1 divided by 3. And our restrictions are 0, 4/3, and -2. And that's it. That's all we need to do on this here. And that brings us to the last type, these complex fractions. Now to simplify out these complex fractions, we're trying to see what do I need to multiply the numerator, everything on top, and everything on bottom by, so that our fractions will simplify out completely on top and bottom. That's our first main step. So what I'm really looking at is these two here. And we can look at the numerator first. So if I look at the numerator, what do I need to multiply 1 over x squared by so that the fraction fully simplifies? Well, that would be x squared. Because x squared times 1 over x squared, well, the x squared and x squared would cancel, simplifying out the denominator. Well, the bottom is 1 over x, so I need to multiply it by x. Well, I already have x squared, so it will simplify. And that's it. So I just need to see what do I need to multiply each fraction by to get it to simplify. Now the 1 over x, because I already have an x with x squared, we don't need to multiply it by anything else. Now we can go on and multiply this. So we're going to multiply it by the top of each of the top fractions. Well, 1 times x squared would be x squared minus x squared times 1 over x squared would be x squared divided by x squared. And we'll simplify that here in a minute. Now we'll do the same thing on bottom. X squared times 1 and x squared times 1 over x. Now x squared times 1 will be x squared minus x squared divided by x. Now at this point here, we do need to factor or simplify down, because x squared divided by x squared would be 1. So that leaves us with x squared minus 1 in the numerator. Now in the denominator, one of the x's on bottom will simplify with one of the x's on top. So we still have x squared, but our x squared divided by x will just become x. Okay. Now we need to do some factoring to simplify down. Well, hey, x squared minus 1 is a difference of perfect squares. So if we simplify this here, it would give us x minus 1 times x plus 1. Did not need the 9. And then on bottom, we have a greatest common factor of x that I can factor out. x times, if I factor an x out of x squared, I'm left with x minus 1, because the other x factored out completely. Well, hey, we do have something in common on top and bottom, so we can cancel that out. So the x minus 1 and x minus 1 would factor. And what that leaves us with is x plus 1. It's going to be highlighting, underlining everything now. All over x. This here would be our final answer. And we do have some restrictions, because we did have something simplify out on top and bottom. And we'd have to say that x cannot equal 1. Now we can list 0, but that's fine. And really for this here, we're not going to do much restrictions with our complex fractions. We're not going to be worried about that. And that's it for this part here. So we'll look at a few more of these here. Okay. Now with this one here, again, we're wanting the fractions to simplify out of the top and bottom, so it's a little bit easier to work with. And if we look at this one here, hey, it's kind of nice, because the only one that has a fraction on top and bottom is the 25 over a. So that's the one we need to simplify. We need to get to simplify. And what do I need to multiply 25 over a by to get the fraction to simplify? Well, that's just going to be a. And we can go on and do that. And if I multiply the numerator by it, so it'll be 25 times a and a times a. So 25 times a would be 25a over a minus a squared. And on bottom, I'm going to flip this around, a times a would be a squared plus 5a. Equals. And again, I'm going to flip it around so I'll have negative a squared up front. Now our a divided by a over here will cancel, which will give us plus 25 over a squared plus 5a. Now at this point here, we need to see, does anything factor out or simplify down on top and bottom? And yes. Now on top, we can factor out a negative 1, because I really want that a squared to be positive. And if I factor a negative out of negative a squared, we're just left with a squared. Now if I factor negative out of positive 25, we're left with negative 25. Okay? And on bottom of this fraction here, there is a greatest common factor of a that we can factor out. And if we factor it out, a factored out of a squared would be a plus 5. Okay, well that just went back to what we did before we multiplied by a. So, oh well. Now, last but not least, we can factor the numerator, because once we factor that negative out, hopefully you're able to see that this is a difference of perfect squares. A squared minus 25 would be a minus 5 times a plus 5. And this here is all over a times a plus 5. And if we look at this here, there is a greatest, or there is something in common on top and bottom that will simplify. And that'd be the a plus 5 and a plus 5. Which leaves us with negative a minus 5 all over a. And this here would be our final answer. And we're not going to worry about restrictions for these here. We're just going to list our final answer. Okay. So we just have a few more of these here. We're going to skip ahead to this one here. Now we look at this one here, we need to see what do I need to multiply each of these fractions by so that the fractions in the numerator, the 1 over x, and this here, will simplify, as well as these here on bottom. So if I look at the ones on top, well, the x over x plus 1, well, if I multiply that by x plus 1, the x plus 1 and x plus 1 would simplify. Now if I multiply 1 over x by x, then it would simplify. So for the two on top, I need to multiply each one by x plus 1 and x. So we'll do the same on bottom. Okay, let's check the ones on bottom. Well, we have an the x over x plus 1, I need to multiply by x plus 1. And the 1 over x needs to be multiplied by x. So, this is what we need to multiply through. So we're going to multiply through with these here. Now on top, our x times x would give us x squared times x plus 1 over our x plus 1 minus. Here we're going to do x times x plus 1 times 1, which would be x times x plus 1 over x. We'll do the same thing with the denominator. X times x plus 1 would be x squared times x plus 1 all over x plus 1 plus x times x plus 1 over x. Okay, now that we did that multiplication, we can simplify out what's in common on top and bottom. Well, the x plus 1 and x plus 1 would cancel. Here the x plus 1 and x plus 1 would cancel. Here the x and x would cancel. And again, here the x and x would cancel. And what that would leave us with in our first one here, well, I just have x squared minus x plus 1 over x squared plus x plus 1. And this here, well, on top, well, we would have x squared, so we need to distribute that negative because we're subtracting. So these here would both become negative. So it become negative x minus 1. And on bottom, it's just going to be x squared plus x plus 1. Now it'd be very tempting to try to factor the numerator, or not factor the numerator and denominator, but try to just cancel things out that are in common, like the x squared and x squared. But they don't cancel because they're being added and subtracted with the other terms in the numerator and denominator. So we can't just simplify those out. And this here, the numerator and denominator do not simplify. So this here is our final answer. That's all we have to do for this here. So with these complex fractions, we start off by multiplying the numerator and denominator by something that would get the fractions on top and bottom to simplify, to get these fractions here and these fractions here to simplify. And once we do that, we combine our like terms, simplify the numerator and denominator, all the way down to get our final answer. And that's all we have to do for these here. Now, if you have any other questions or have questions over the homework assignments, please let me know, email me, get in contact with me. And hopefully I'll be able to see y'all tomorrow.